Hello, today we want to do an example for chapter 4, which is multi-degree of freedom system. Okay, this is the questions for this an example. A disc of mass m and radius r that rolls without slippage is attached to a rod of length L and mass m as shown in figure 1. For the first questions, draw the free body diagram of both body clearly, showing the active force. For the second questions, use either Newton's law or Lagrange methods to derive the equations of motions using generalized coordinate x1 and x2. For the third questions, find the natural frequency and mode shape vector if m equal to 1 kilo, k equal to 100 Nm meter, l equal to 3r and r equal to 0.1 meter. For the last questions, obtain the response of xt only if x1 equal to 0.01, x2 equal to 0, x.1 equal to 0 and x.2 equal to 0 at t equal to 0. Okay, here is the figure 1 of these questions. As you can see, there is a disc and the rod that attached with a spring. The first step we need to do is by drawing the free body diagram. Let's make an assumption that the x2 is greater than x1. So here how the first force will act on the disc. Okay, this is how the second and third force that acting on the disc and the rod will be like. And here is the last force that acting on the rod. At the rod, we have mg. Okay, we need to find the mass 1, which is the mass 1 is at this. The summations of moment 1 is equal to I theta double dot and it is rotated counterclockwise. Okay, so this is the working calculation to find the equations of motion for the disc. As in animation, it shows that x double dot equal to r theta double dot and theta double dot is equal to x double dot over r. As shown in the second animations, it shows that formula for I disc is equal to 3 over 2 mr squared. Those value is substitute into the equation to get the final equations of motion. And here the equations of motion for the disc. Next, find the equations of motion for mass 2, which is at the rod. It is same, the summations of moment 2 is equal to I theta double dot and it is rotated counterclockwise. So here how the working calculations for the rod to find the equations of motion. In this animation, it shows that the theta double dot is equal to x double dot over L and theta is equal to x over L. And as shown in animation 2, the I for this rod is equal to 1 over 3 ml squared. Those formula is then substituted into the equation to get the final equations of motion for the rod. And here how the final equations will be look like. Then the both final equations of motion will be put in the matrices as shown in the box. Okay, to answer the second questions, let's start by find the natural frequency, which is omega. Okay, as shown in the box is the basic questions to find the natural frequency. Then we will arrange the matrices that we get earlier become like the basic equations of the natural frequency. As shown in the animation below, the value of K is equal to 100 Newton meter, the value of M is equal to 1 kilogram, the value of L is equal to 3R, and the value of R is equal to 0.1 M. All those values has been given earlier in the equations, and all the value will be substituted in the matrices. Then after the substitutions, the matrices will be like this. Then we will make the equations from the matrices to find the omega. To make it easy, we let omega squared equal to lambda. So there is how the equations will be. From the equations, we will get omega lambda 1 is equal to 1304.33, and then we will get the omega 1 is equal to 36.12 rad per second, and also we will get the lambda 2 equal to 145.67, and the omega 2 will be 12.07. Okay, to answer the question 3, we find the mode shape for the first omega that we get from the question 2, which is 36.12 rad per second. As shown in the box, it is the basic equations for mode shape. Then we will arrange the matrices to be like the basic equations to find the mode shape. So here how the matrices will looks like, and the value that have been given in the question 1 or in these questions will be substituted into the matrices, so that it will be like these equations have been shown in the box. Then we will rearrange the equations to get the first mode shape. And the first mode shape is equal to 1 minus 2.64 S1. For the second mode shape, which is at omega equal to 12.07. Okay, same, it shows the basic equations in the box, and we repeat the same step that we have been done earlier to find the mode shape 2. All the value of K, M, L and R has been substituted in the matrices and will be like this. Then we will rearrange the equations from the matrices. Then we will arrange the equations again to find the final mode shape for omega 12.07, and the mode shape is equal to 1.70 x1. Okay, for the last question, to answer the last questions, which is time response x1, we need to know the equation. Okay, this is the basic equations to get the xt, which is time response. Okay, this is the first questions, which is for x1t. The equation will be look like this after we substitute all the value that we get earlier. Okay, for the equation 2 is for x2t, and the equation will be look like this. For the third equations, it is for x dot 1t, and the equation will be look like this. And for the final equation, which is equation 4, is for x dot 2t, and the equation will be look like this. In the box, it shows the value of x1 which is equal to 0.01, value of x2 which is equal to 0, value of x dot 1 which is equal to 0, and value of x dot 2 which is equal to 0. All the value I have given in the questions, and then we will substitute the value on the equation earlier, which is equation 1, 2, 3 and 4. And okay, for the equation 1 it will be look like this, and equation 2 will be look like this, equation 3 will be look like this, and equation 4 will be look like this. Then we need to find the phi to answer the question. To find the phi, we use the simultaneous equation. Okay, the first question, which is x dot 1t, will be times with 2.64, and the second equation is for x dot 2t. Then the third equation that we get is the final questions after we times the equation 1 with 2.64. Then we use elimination method to find the phi 2. After we get the phi 2, we substitute the value into the equation 1. So here how the substitution is done. Okay, and the answer is phi is equal to 0, which is phi 1 equal to 0. Okay, for the second step, we find A1 and A2 using the same step, which is simultaneous equation. The first equation, which is x1t, will be times with 2.64. This is because we want to eliminate A1. Okay, for the second question, x2t. For the third equation, it is the final equations of x1t after times with 2.64. Okay, then equation 6 plus the equation 5 to eliminate A1. So the value A2 that we get from that is 6.083 times 0 negative 3 times 10 negative 3, sorry. Then we substitute the value of A2 into equation 4. So here the substitution is done. So the A1 that we get is 3.917 times with 10th power of negative 3. So here the x1t will be. That's all from us. A big thank you from us because you all have seen this video, and goodbye.